Let's look at some problems on the Achieve 5.3 assignment together. Starting off, it should remind you of some fond trigonometry memories. They don't necessarily simplify the way I would in this problem, but let's take a look at how they work out this problem. They're asking us to simplify the expression 9 cosecant x minus 9 cotangent x over secant x minus 1. Now, what I've done when I simplified that, and it will match their answer, is their first part, they're just wanting you to understand that the cosecant is 1 over the sine, the cotangent is cosine over sine, and again, the secant is 1 over cosine in the denominator, of course, minus our 1. Now, that's going to match their first answer that they want us to do. It says, select the expression equivalent to this. And so we have our very last one, 9 times 1 over the sine of x minus 9 times cosine over sine divided by 1 over cosine minus 1. Has to be that one. Okay, now I'll move on down. And then it's asking us to further simplify this expression. Well, notice what they've done in this case. They've pulled out the common factor of 9 in the numerator, and then they've got a common denominator of that sine of x, and then they just said, well, it's going to be 1 minus cosine x over sine of x in that numerator. And then they've got a common denominator in the denominator. They had to force the second one, the 1, to understood to be cosine x over cosine x. So it becomes 1 minus the cosine x over cosine x as well. And you'll see that's what I did right here in this step. I factored the 9 out. And then I said, well, then what's left over, both terms will have a denominator of sine x. The numerator of that expression is going to be 1 minus the cosine. So I have 1 minus cosine over sine after I factor the 9 out in front. My denominator, 1 over cosine minus cosine over cosine, can be rewritten in better format as 1 minus cosine over a common denominator of cosine. Now, the advantage to that is then I can say, well, anytime you divide by a fraction, you can multiply by its reciprocal. So I have the numerator I just brought down divided by, instead of dividing, I'm multiplying by the reciprocal of the denominator, which means the cosine goes to the numerator divided by 1 minus cosine. I can quickly see that the 1 minus cosine cancels, and I'm left with 9 times cosine over sine, which is just 9 cotangent x. Now, to answer the rest of the problems in their expression, they'll want this format for the second one, 9 times 1 minus cosine over sine divided by 1 minus cosine over cosine. So when I try to find that here, my numerator, 1 minus cosine over sine, my denominator, 1 minus cosine over cosine, it has to be the last choice here. And then when this simplifies out, like I said, it's going to reduce down. Those 1 minus cosines cancel, and you're left with cosine over sine, which is cotangent. Has to be the last one. We'll check that. And it says correct. Now the next question is just, again, one of these where it's going to ask you to watch a video, and it's going to talk about the basic trigonometric identity integrals that you need to be familiar with. I'll let you watch that as you work the homework assignment. So I'll go ahead and move to the next one and look at their problem that's based upon that. So this one's similar to the first one in that you cannot go ahead and attack it unless you can simplify it down first. So they give me the expression, the integral of 6 cosecant x cotangent x secant x. I have to understand that cosecant is rewritten as 1 over sine, cotangent can be rewritten as cosine over sine, and secant can be rewritten as 1 over cosine. That allows me to quickly and easily see, well, the cosines can cancel out here. I'm just going to be left with 6 times 1 over sine times 1 over sine, 6 times 1 over sine squared. I know that the reciprocal of sine is cosecant, so the reciprocal of 1 over sine squared is cosecant squared. So now I'm trying to work with the integral of 6 cosecant squared x. And again, remember, this is like playing Jeopardy with the problems. We have to think back to Calc 1 and say the derivative of what involves a cosecant squared. And you might remember, well, the derivative of cotangent is negative cosecant squared. So the derivative of a negative cotangent would be a positive cosecant squared. And then I can carry over, well, what happens to that 6? Well, it just gets carried through. And I can say, well, then the derivative of negative 6 cotangent of x would equal positive 6 cosecant squared x. So this would be my integral. I always have to put the plus the constant of integration. Something I wanted to mention here is that it is completely unnecessary to put parentheses around an angle, especially when it's just a simplistic angle like x. However, for your final answer in the achieved system, it will require parentheses around any angle, even if it is just an x like that. So they want the answer just like that question was written with the parentheses around the angle. You don't have to put it throughout the problem. It's certainly not necessary, but in the answer you do. So I'll say, okay, this one is wanting -6 and cotangent x, cotangent. And notice as soon as I type in the COT, they go ahead and put the parentheses there for me. And I'll say plus the constant of integration, just plus a capital C. And you could also use their C down here. But I think the C just on my keyboard is fine. Let's see. And it is. Next question, number 4. So number 4 is a little bit of a strange problem here. They're asking us to select all the expressions that are equivalent to this original rational expression where you have to simplify with exponents. Well, if I were simplifying with exponents, I would put the a to the 7th in the denominator. I would put b to the 4 plus x in the numerator, and I'd leave the c squared down in the denominator. So basically, the way I would simplify would be their answer for part 3. You'll see where I did my work here. Their answer for part 3, their third answer, I feel is the best answer, because you'd say, well, I should always keep the variable where the larger power is. I'll assume 4 is larger than -x, so the b should go up to the numerator. Whenever I do that, I always subtract 4 minus a -x becomes 4 plus x, or x plus 4. Similarly, the a belongs in the denominator. It'd be 2 minus a -5. That's 2 plus 5 is 7. And the c squared can stay down there. So obviously, I know the third choice is correct. So I'll go ahead and mark that as correct. What's wrong with the second choice? Well, the second choice, you can see the a to the 5th is still in the numerator. It moves the a to the 2nd up there, and it would be an a to the -2 up there, so that's no problem. B to the -x still down there. The problem with it is you can't just move a b to the 4th from the numerator to the denominator and not change the sign of the exponent. So number 1, or the first choice, wrong. Second choice is right. When I did that second choice, I just said, well, all I would have to do, the b to the 4th stays up there. If I move the a down to the denominator, it's going to be 2 minus a -5 for 2 plus 5. I get a to the 7th, and then nothing else has changed. So clearly the second choice is correct. And that's our only 2 choices. What's wrong with the 4th choice? Why didn't I like it? Well, the a to the -3 in the numerator. If you wanted to collect a in the numerator, this would have to be -5 minus 2. It'd be an a to the -7 in the numerator. That's wrong. Similarly, the a is wrong in the next one too, because if you wanted to collect a in the denominator, it'd have to be 2 minus a -5. It'd be to the 7th power down there, not to the -3rd. So the a's eliminate both of the last 2 from consideration as being correct. It's only the 2nd and 3rd one. We'll check that, and it says good. This one's going to be a similar problem if it loads. It finally loaded here. So when I was looking at this one, the way I would go ahead and just simplify this, what you're supposed to remember, power to power, you multiply. So this is just e to the x plus 9 raised to the 2nd. 2 times x plus 9 is going to be 2x plus 18. that's the best simplification. So the one that I would do is their third answer there. Now, I was looking to see what other ways it could be rewritten, and we know anytime you have e to the 2x plus 18 power, well, whenever we have like bases that are multiplied, you would add their exponents. So I could break that apart and say that's the same thing as e to the 2x times e to the 18th. And then when I combine them, it would lead me back to e to the 2x plus 18. So I know that the fourth choice that they that they have there is also correct. And then I was thinking about it and saying, well, how else could we rewrite that? Their second choice is correct because e to the 2x, that's the same thing as e to the x raised to the second. Remember, power to power, you'd multiply. So you'd say, well, that's the same thing as this. And then e to the 9th raised to the second, it's the same thing as e to the 18th. So I can say the second, third, and fourth choice here are all correct. Second, third, and fourth. Why is the first choice wrong? Because that would be x plus 9 raised to the second power. That's not what happens here. Power to power, you multiply. You don't take x plus 9 raised to the second power like that. So that's just bad algebra there. And similarly, the last choice is horrendous algebra. That's somebody trying to raise x plus 9 to the second power and not doing it correctly and thinking, oh, I can just square the first term and square the second term. It never works that way. And plus, we're not raising to a power here. In this case, whenever we have a power to a power, you multiply, not raise to the power. So it's just the second, third, and fourth choice for the correct answers. And we say that should be right, and it is. The next one, again, it's going to give you a video to watch. In that video, they're going to discuss the evaluation of exponential functions where the key concept there is what's written right here. The integral of e to the kx plus b with respect to x is going to be 1 over k e to the kx plus b plus c. We talked about that in the notes for the section as well. That'll be a good video to watch. Ooh, I want to make sure I get credit for it, so I will hit play. And then ding, I get credit. Then I'll move on. Now, for number 7, gorgeous problem. When I'm looking at this, I'll show you the work that I did here. We have the integral of negative 15 over x to the 6th plus e to the 3x minus 7 power with respect to x. So what I did there is I just said, let's go ahead and rewrite the first one. That's the same thing as negative 15x to the negative 6th plus e to the 3x minus 7. Didn't have to change the second one. This allows me to use the power rule more easily. And I'm going to say x to the negative 6 becomes x to the negative 5th. So I'll have negative 15 x to the negative 5th divide by that new exponent. And then the integral of any exponential function is that exponential function divided by the derivative of its exponent. Then I had to say plus the constant of integration. I simplified here, negative 15 over negative 5, simplified to be 3. The x to the negative 5th is much better written in the denominator as x to the positive 5th. So I have 3 over x to the 5th plus, this is better written as 1/3 e to the 3x minus 7 plus our constant of integration. I'll go in here and put that answer. I'd rather this stay in instead of disappear. So I'll make it stay. Now, I'll go up here and say I have 3 over x, and then that x is raised to the 5th power. And then we're adding that to 1/3. And that 1/3 is multiplying the exponential function base e. And then that is raised to the 3x minus 7 power. And then we can say plus our constant of integration plus capital C. That should be correct. And you can see it is. Next question for number 8. Again, it's one of those that it's going to have you read some stuff and they're just talking about the distributive property of multiplication. This is going to become important whenever we have terms that you need to multiply inside the integral, you have to remember to carry out that multiplication. Do the algebra before you do the calculus. So this is just going back to a very basic problem where you're multiplying a trinomial times a binomial, and all you have to do is make sure that you distribute every term in the first group into every term in the second group. So I took the 3x to the fourth times both of these terms, and I got 24x to the sixth plus 6x to the fourth. You take the 5x squared, multiply them both, you get the 40x to the fourth, and then the 10x to the second. You multiply the 7 by both of those terms, you get 56x squared plus 14. Then I collected any common terms. You had 6 and 40 combined to be 46x to the fourth. 10 and 56 combined for the coefficients of x squared to give me 66x squared. For my final answer there of 24x to the sixth plus 46x to the fourth, plus 66x squared plus 14. And there's only one answer remotely like that. It's the last one. And so I'll check that, and it better be correct. And it is. For number 9, this one, I'm kind of not sure why this one in here. I think it's kind of bizarre for this section. It's just giving you a basic polynomial, fourth degree, 4x to the fourth minus 5x squared plus 6. And then it's asking you, hey, evaluate that at 5. So you know you're just plugging 5 in for x. You'll have 4 times 5 to the fourth. Minus 5 times 5 squared plus 6. This will be 4 times 625 minus 125 plus 6. When I did this on the calculator, I got 2381. And we'll put that up here, 2381, and check answer. Yes. For number 10. Number 10 is again a problem that has a media question, and what they're trying to do here in this video example is remind you of how you're going to work backwards and have to solve for C whenever you have initial conditions. So it's a really good video to watch to make sure you understand the techniques of solving what's called initial value problems. We discussed that in the notes, so I will go ahead and go beyond that. And here's our initial value problem similar to that. I will pull up my second sheet of my homework here. So in this one, it's giving me the derivative of y with respect to x, and it's giving me what the function is evaluated at x equals 3. It's telling me that the original function when x is 3 is equal to 4. So before I can do anything, I have to remember, before I can integrate, I must do the algebra and distribute first. So that's what I did. I distributed the 4x squared throughout the second group, and I got 16x cubed minus 12x squared, distributed the 7 and got 28x minus 21. Now we integrate term by term. The first term would have become 16x to the fourth over 4. I wrote it as 4x to the fourth. The next term would have been minus 12x to the third over 3. Simplified that to minus 4x cubed. The next one would have been 28x to the second over 2. Simplified that to 14x to the second. And then the last one, remember, this is just 21x to the 0, so power rule makes it become 21x to the first, technically divided by 1, plus your constant of integration. Now we're trying to solve for that constant of integration. So what did I do? I plugged 3 in the place of x in my function. I have 4 times 3 to the fourth became 4 times 81, minus 4 times 3 cubed is 27, plus 14 times 3 squared is 9, minus 21 times 3 plus c, and I know that all of that has to equal 4. So calculator told me that the sum of all of those products and differences here was 279. I get 279 plus c is equal to 4. Thus, I can solve for c and say, well, c is just 4 minus 279. It's a negative 275. Remember, the 3 dots means mathematical notation for therefore. So I said, therefore, the final answer is what I had here with the value of c that I know, the minus 275. So my final answer here should be 4x raised to the fourth. And then I have minus 4x raised to the third. and plus 14x squared, and minus 21x, plus our constant of integration, plus c. That should be what they want. We'll check that. Oh, sorry. We don't want the plus c. What am I thinking? That was just an opportunity for me to show you, hey, remember, you get to try these as many times as you want, and silly me, I just had to replace the c. The whole point in solving for c is to plug it in. Minus 175. So minus 275. I'm determined to miss this problem. Minus 275. Check answer. Yes. And it has to remind you, you solved it in 2 attempts. Gee, thanks. But it gives you full credit. So now the next one, super easy problem, super easy. It's just asking us to integrate 27x squared with respect to x. So you said, well, it's just the power rule. Becomes 27x to the third over 3 plus your constant of integration. 27 over 3 reduces down to 9. This is just going to become 9x raised to the third and then plus c. And that should be correct. And it is. For number 13, again, pretty straightforward problem. It's asking me to integrate the function 2 cosine x minus 3 sine x with respect to x. So I can say, well, and I wanted to go ahead and draw this for you over here. This really helps out a lot of students because instead of having to sit there and think about, okay, the integral and the derivative of my trig functions, in terms of sines and cosines, you know sine is the y component on the unit circle, and positive when it goes up, negative when it goes down. Cosine is the horizontal component on the unit circle. So we can say, well, it's positive when x is positive, negative when x is negative. So now, if I were taking the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is sine. Well, what if I wanted to integrate? Well, integrate, you just go in the clockwise direction. The integral of cosine is sine, the integral of sine is negative cosine, the integral of negative cosine is negative sine, and just like that. It's a little easy mnemonic that might help you out, and make sure you don't make any sign SIGN errors when you take these derivatives. So I'm trying to, or I should have said integrals. When I'm trying to integrate the cosine, I can say, well, the integral of cosine should be sine. It is. The 2 just goes along with it. When I'm integrating a negative sign, integrate a negative sign, it should be a positive cosine. It is. So notice minus 3 sine becomes plus 3 cosine. And I had to go ahead and put the parentheses around the angles for my final answer. And of course, stick in the plus the constant of integration. So now I'll say, well, my answer should be 2 sine x, 2 sine, and notice as soon as you type in sin, it's going to put the parentheses there for you. And then I have plus 3 cosine, and again, parentheses automatically. And I'll arrow to the outside of the parentheses and say plus the constant of integration plus c. And correct. For 14 here, 14's given me an exponential function and a negative exponent term, no big deal. If I'm integrating that, I know that the integral of any exponential function is that exponential. Technically, I would say divided by the derivative of its exponent. That's just a 1 in this case. The x to the negative 2, when I add 1 to that exponent, becomes x to the negative 1. So I say minus 11x to the negative 1 divided by that new exponent of negative 1. That's going to make this be a plus 11. And then that x to the negative 1 goes to the denominator and becomes plus 11 over x, plus the constant of integration. So we can just say this should be 2e raised to the x power. And then let me make sure I didn't do a capital X there. It looks like a capital X, but it's not. And then plus 11 over x plus our constant of integration. And that should be the correct answer. And it is. Last one I'll do in this video, and then we'll look at some others, the rest of the problems in future videos for this section. For number 15 here, it's wanting us, and this is a very easy one to end on, the integral of 29 minus 18x. It's a simple power rule for both of these terms. You need to understand that this first one is understood to be 29x to the 0. So the power rule says, well, increase the power on x by 1. It becomes 27x to the first then. And then the integral of 18x to the first is going to be 18x to the second divided by 2. And then, of course, we keep the sign out in front. So we have 29x to the first minus, this is going to simplify to be 9x squared plus the constant of integration. I don't see any need to rewrite it in descending order. You could just keep it in the order of the original expression. Doesn't matter either way. It's going to count it correct no matter what you choose to do there. 29x, and then we have minus 9x raised to the second plus our constant of integration. We check that answer. Nice. All right, guys. So this hopefully will help you with the first 15 problems in this assignment. Like I said, we'll pick up with another video with the others. Let me know if you have any questions on these.